Hello, in this video I'll try to explain the interface and control of DC motor pertaining to embedded controller lab. So the DC motor is a class of rotary electrical machine that converts direct current electrical energy into a mechanical energy. Essentially DC motor consists two terminal. If the proper supply is given to those terminal, the motor will rotate in anti-clockwise direction, and if the polarity of the supply is reversed, the direction of the motor also subjected to change. So let us look into the schematic. So again, the DC motor is a high load device. So this DC motor cannot be driven, that means your microcontroller cannot be drive the DC motor directly. Hence there is a requirement of motor driver. Here ULN 2803 is used as a DC motor driver, and also we are using a double pole double throw relay to control the direction of the DC motor. Look into the schematic. The 18th pin, that means the output 1 and output 2 of the controller, driver 2803 is connected to the normally closed and normally open terminal of DPDT, and these two corresponding input ports, that is out 1 corresponds to in 1 and out 2 corresponds to in 2, they are short together and connected to input IN6 terminal. Okay, so this IN6 terminal in a connector 5 corresponds to 6th pin. So at the microcontroller side, the 6th pin of the connector A corresponds to 9th pin of port 0. So the 9th pin of port 0 is used to create a ground path for DC motor at the driver side. That means whenever you apply logic 1 via 9th pin of port 0, that means your microcontroller should send logic 1 through the 9th pin of port 0, then your driver will make 18th and 17th, that is out 1 and out 2 of the driver will create a ground path for the DC motor. See, those ground paths are connected to normally closed terminal and normally open terminal of the DPDT respectively. See, this DPDT consists, that means the DPDT relay consists of two poles. The first pole, normally open terminal of the pole is connected to plus 5 volts, and normally closed terminal is connected to the ground path of the driver, and similarly the normally open terminal of the second pole is connected to the ground terminal of the driver, as well as the normally closed terminal of the second pole is connected to plus 5 supply. So, and this is a relay coil. So this relay coil will get energized when the out 3, okay, that is out 3 corresponds to in 3. When out 3 creates the ground path, when the out 3 becomes 0, the relay will get a proper power supply, that is relay coil will get a proper power supply, and the relay will get energized. Okay, during that time the switch position can subjected to change from normally closed terminal to, so normally open terminal to normally closed terminal. So corresponds to the relay pin, that is terminal number 16 corresponds to out 3, which is subjected to in 3, which is in turn connected to input 7 terminal. So the input 7 terminal of a connector is corresponds to 7th pin of connector A5. So the 7th pin of connector A5 in turn connected to the 10th pin of port 0. So therefore the 10th pin of port 0 is used to control the relay. Okay, that means the relay will be switch on or switch off based on the value that your microcontroller sending through the 10th pin of port 0. See, whenever the 10th pin of port 0, that means the 10th pin of port 0 is 1, that means when your microcontroller is sending logic 1 via this 10th pin, then obviously the correspond the 16th, that means out 3 of the driver will create a ground path for the relay. Relay will get energized, and the switch positions of the poles will take changes from normally open terminal to normally closed terminal, and the direction of the DC motor become clockwise direction. And when your microcontroller send logic 0 via 10th pin of port 0, in turn it is going to de-energize the relay. So the switch positions it's as shown in the schematic diagram. During that time the DC motor follows the anti-clockwise direction. Okay, so here always these two terminals should have a grounded path. That means in 6 terminal should be always 1. Therefore always you have to send the ninth, that means your microcontroller should send logic 1 via ninth pin of port 0. So this pin must be always 1, so that your motor will be either in the clockwise direction or in anti-clockwise direction. But the direction of the motor can be controlled by switching on or off of the relay. The switching on and off of the relay can be controlled with the help of 10th pin of port 0. This is about the schematic. Now since we identified two pins, so we have to configure these two pins as general purpose input output pins, and we have discussed the corresponding pin selection register functions in the earlier video. Since both these pins are pertaining to port 0 and they are within 0 to 15, pin selection 0 can be used to configure these two pins as general purpose input output pins, and those particular register positions should be made as 0 0 and 0 0, and remaining register position should be assumed as 1, so that the other pin functionality will not be get affected. So the corresponding instruction becomes LPC underscore pincon pin selection and is equals to 0xFFC3FFFF. That means this is the corresponding hexadecimal value. This hexadecimal value should be ANDed with the original content of the pin selection register. So only the 9th and 10th pin of the port 0 will be configured as a general purpose input output pin, and remaining pin functionality will doesn't alter. So this is the statement to configure these two pins as general purpose input output pins. Now let us set the direction of the pins. Since your microcontroller need to send the value through these pins, these two pins must be act as output pins. Okay, so the corresponding position of these two pins must be made it as 1 1 in the FIO DAR register, that is fast input output direction register, and the rest of the pin direction should not be altered. Therefore the corresponding value is 0 0 0 0 0 6 0 0. This is the corresponding hexadecimal value, and this hexadecimal value should be odd with the original content of the direction register, so that only the desired pins will that means will change as an output pins, whereas rest of the pins of port 0 doesn't change their direction. Now if you want to switch on the DC motor, you have to set that means you need to send logic 1 via the 9th pin of port 0. That's why you have to use FIO set pin. So FIO set register. So in this register the corresponding position, that is 9th position of the register, should be made it as 1, so that you are ensuring through the 9th pin of port 0 you are sending logic 1, so that you are going to create a ground path at the driver. So the corresponding value is 0 0 0 0 0 to 0 0. So the instruction is LPC underscore GPIO, because this FIO set comes, and this pin is in port 0. That's why you have to use the structure LPC underscore GPIO 0. So within that you have to use the register FIO set. So using this register you are sending logic 1 via 9th pin of port 0. Similarly, the relay can be controlled by setting or clearing the value corresponds to the 10th pin. So either you can use FIO set register or FIO clear register. So it is supposed to be FIO clear register. So by using FIO set register you can send logic 1, and by using FIO clear register you can send logic 0. In turn you are going to control the relay, and in turn you are going to control the direction of motor. So this is about the program. So you have to include header file, and you are initializing the main program, and after the main program if any local variable is required you can declare that. After declaring the local variable, it is mandatory to declare the two system function, that is system initialization and system core clock update. As I told, these two are the CMSAS function. They are they are essential to update the clock value. Now this is an instruction. So this is a instruction to configure the port 9 and port 10 as a general purpose input output pins, and this is an instruction, as we discussed earlier, to configure those two pins as output direction. And this is an while one, it's an infinite loop. Now initially we have to set the 9th pin of port 0, so that we are creating the ground path at the driver, so the motor will be run either in anti-clockwise direction or in clockwise direction, depends upon the relay status. Now here if we are going to clear the relay, that means by using the clear register we are sending logic 0 via 10th pin of port 0, thereby the relay will be off, so that our motor will be rotating in anti-clockwise direction. After some amount of delay, we are setting the 10th pin of port 0, thereby we are sending logic 1 via this 10th pin, so hence the relay will get energized, so that your motor will be rotating clockwise direction. So continuously the motor will rotate in anti-clockwise and clockwise direction over a span of time. This is about the program flow. And thank you, and you can watch the demonstration video at the end of this slide.